prove that the midpoint of the hypotenuse of right angle triangle is equidistant from its vertices. Okay, now let us say you have a right angle triangle. Okay, this angle is 90 degree, and let's say this is the midpoint of the hypotenuse. Okay, now let us say this is point A, this is point B, this is point C, and this is point D. Now this AB and AC, they are mutually perpendicular. Okay, and since D is the midpoint of BC, so BD, that is this vector, will be equal to DC. Okay, that will be equal to DC vector. Okay, and since they are equal also, they are equal in magnitude and they are parallel to each other because they are along the same line, and point D is the midpoint of BC. Therefore we can write this equation. Now let us say we join this point A to point D. Okay, now if I wish to write AB, I can write it as the resultant of the vector AD and DB, okay, which can be further written as AD minus BD. Okay, is that clear? Now similarly vector AC can be written as a resultant of vector AD plus DC. Okay, and we know that DC, this vector, is equal to this vector, so this can be written as AD plus BD. Okay, this we already know. Now it is also known that AB and AC, they are mutually perpendicular. So vector AB is mutually perpendicular to vector AC, therefore their dot product AB dot AC will be equal to 0. Now what is AB? AB is given by AD minus BD. Okay, and what is AC? AC is given by AD plus BD. Okay, and this should be equal to 0. Now if we apply the distributive law property of scalar multiplication, we'll be getting it as AD squared minus BD dot AD plus AD dot BD and minus BD square, which is equal to 0. Now this term, by commutative law, these terms will be equal and they will cancel out each other. So AD square is equal to BD square, which means that AD is equal to BD. Okay, so this is equal to this is equal to this. The midpoint is equidistant from the vertices, that is A, B and C. So using scalar multiplication we found out this relationship.